Module 2 Test Review, Reviewing Graphs and Functions. Question 1. Write a related function for 8x minus x plus 14 equals 2x. When they want you to write the related function, they're asking you to write it in slope-intercept form, but write it as f of x instead of y. But if you want to write it as y equals mx plus b, that is okay as well. So the first step we want to do is just combine our x's on the left side. So 8x minus 1x is 7x plus 14 equals 2x. Now we need all of our x's to one side, and we need this equation to equal 0. So if I subtract 2x on both sides, I now have 0 equaling 5x plus 14. Now instead of 0, we can use f of x or we can use y. So our related function in function notation would be f of x equaling 5x plus 14, or in slope-intercept form with y, it would be y equals 5x plus 14. Question 2. Write a related function for 9 minus 1/3 x equaling 7, and then use the graph to find the solution. So we want to do the same thing we did in question 1, but this time with question 2. So I'm going to subtract 7 on both sides, and I'm left with 2 minus 1/3 x equaling 0. Now instead of 0, we can use f of x or y. So I would have f of x equaling, and since I want to put it in slope-intercept form, I'm going to put my x term first. So that would be a negative 1/3 x plus 2. Or if you can put it as y equals a negative 1/3 x plus 2. Now if you were to still keep it as f of x equaling 2 minus 1/3 x, that is still the same. Now the question is, use the graph to find the solution. The solution is where it crosses the x-axis, and since the x-axis is the x-coordinate right here crosses the x-axis there, so our x-intercept would be 6, 0. So that means when y is 0, our x is going to be 6. So if I put 6 in for x, 6 times negative 1/3 is negative 2. Negative 2 plus 2 is 0. So our solution is 6. Question 3. What are the coordinates of the x and y intercepts? So for the x-intercept, your y is 0, and you have to find your x. So if I go to my graph here, the x-intercept is right at negative 2. So I would have negative 2 is 0. And the y-intercept would be when x is 0, what is the y? So I go to the graph, it crosses the y-axis here, which would make that a positive 4. Now we need to describe where the function is positive and where it's negative. Now if it's above the x-axis, it's positive. When it's below the x-axis, it's negative. And now everything is going to be based upon where it crosses the x-axis. So let's do the positive part first. The positive part right here is above the x-axis. When it's to the right of the x-intercept, it's greater than. And when it's less than, or when it's to the left of the x-axis, it's less than. Okay, so now let's do the positive part first. So the function is positive when x is greater than negative 2. Because the x-intercept's at 2, so everything to the right of negative 2, it's greater than. It's above the x-axis. and then it's negative when x is less than -2. So when it's to the left of -2, it's below the x-axis, making it negative. Question 4 says use the graph to describe where the function is positive and negative. Again, we're going to identify our x-intercepts, which is at 1 and at 4. And it's positive when it's above the x-axis, and it's negative when it's below the x-axis. So it's positive from 1 to 4. So we were going to say positive when x is between 1 and 4. You could have also written it as when x is less than 4 but greater than 1. Either way works. Next part is the negative part. Now it's negative down here. That means it's to the left less than 1. So when x is less than 1, it's negative. It's below the x-axis. And when it's negative, it's down below the x-axis here when x is greater than 4. So it's always going to be the opposite of what the other one is. So if the positive is between 1 and 4, that means it's negative less than 1 and greater than 4. Question 5. Determine whether the relations are functions. Now, for a relation to be functions and you're given ordered pairs, the x's cannot repeat. So if I look at my x's, I have a 2, I have a 4, I have a 3, a 5, and a -2. None of it repeats. So this is a function. That means we have one x value matched up with exactly one y value. Second example. We have a 6, we have a -4, we have a 5, we have a 4, and we have another 6. Since the x's repeat of positive 6 and they have two different y values, that's a red flag, not a function. And our last example. Here we have a mapping diagram. You want to focus on the domain. And with the mapping diagram, you want one line leaving each number. And since I only have one line leaving each of the domains, this is a function. Question 6. Determine which graph is a function and explain why. So if they're giving us a graph, we can just draw a vertical line through it and use the vertical line test. If it crosses once, like this one, this is a function because it passes the vertical line test. And if we look at the one on the right and I draw a vertical line, let's say I drew it here. It crosses in this place and this place. Since it crosses in more than one spot, no, this is not a function. It fails the vertical line test. Question 7. For f of x equaling -2x plus 9, find the value. So for these types of questions, the number they put in parentheses is the number they want you to put in for x in the function. So I'm going to have negative 2 times 4 plus 9. And then after I put 4 in there, they're telling me now to add 3. And this is going to give me negative 2 times 4 is negative 8. Negative 8 plus 9 is 1. 1 plus 3 is 4. The second example, they're telling you to put 5 in for x. So I'm going to have a negative 2 times 5 plus 9. And I want to solve when x is 5. Negative 2 times 5 is negative 10. Plus 9 is negative 1. Then it tells you to put a 1 in for x. So I'm going to do the same thing, but I'm putting a 1 in for x instead of a 5. So negative 2 times 1 plus 9. Negative 2 times 1 is negative 2, plus 9 is 7. Once you have your two answers, they're telling you to take your two answers and subtract them. So negative 1 minus 7 gives you a negative 8. And negative 8 would be your solution. Question 8 says determine whether the function is discrete, which means the points are disconnected. They're not connected at all. Continuous, which means there's no jumps, breaks, or gaps in the line. It's just one continuous flow. Or neither, where it's some of the dots are connected and others are not. So in the upper left one, I have some dots and some of them are connected. So this one is neither. The one on the right, there's no jumps or gaps into the line. It's just one continuous flow, so this would be continuous. And the very last one, I just have a bunch of disconnected dots, which would make this discrete. Question 9. Here it's saying use y2 minus y1 divided by x2 minus x1, which is the slope formula, to determine if each table represents linear or nonlinear functions. Now, do you have to use that? No, you don't have to do that, but it does make it a little bit easier. So I'm going to use the slope formula to solve this one, and I'm going to choose these 2 points, and I'm going to choose these 2 points. And the reason why I'm choosing those two is because the x's are only 1 apart. So now, these are going to be, this will be my x1, y1, x2, y2. So it's going to be 0 minus a negative 3 divided by 0 minus a negative 1, which will make this a positive 3 over 1, which means I have a slope of 1, or a slope of 3. If I do these, this would be x1, y1, x2, y2. So I'd have 9 minus 6 divided by 3 minus 2, which will give us 3 over 1, which means I have a slope of 3. The slope of 3 is the same, so this one would be linear, because linear functions have a consistent or a constant slope. The second example, here, I'm going to use these top 2, and then I'm going to use these next 2 here. So this would be x1, y1, x2, y2. So I have negative 1 minus 0 divided by 1 minus 0, which will give us negative 1 over 1, which gives us a slope of negative 1. Next one, I have x1, y1, x2, y2, and I'm going to have negative 27 minus a negative 8 divided by 3 minus 2, which will give us negative 28 plus 8, which will give us a negative 19 over 1. The slopes are not the same, so this one would be nonlinear. Next, here we have to identify if functions are linear or nonlinear based on the equation. Now on the left here, I'm going to write some notes to help you determine if it's linear or nonlinear. Linear functions can be written in y equals mx plus b format. It could be ax plus by equals c, which is standard form, or you could have it as y equals x, or x equaling a number, or y equals a number. For nonlinear, you would have exponents. You would have 1 divided by x, or you're dividing by x, or you might see one where you're multiplying x times y involved. So now if we look at our examples on the right, we have 4x times 2 minus y equals 9. Now if I were to distribute the 4x, that would give me 8x minus 4xy. That's a key right here. The xy tells us that it is nonlinear. Next example. Here I don't have any exponents. I don't see any x's times y. If I were to add 2x to both sides, I would have 2x minus 3y equals 5, which looks like standard form of ax plus by equals c. So this one would be linear. Next one, I have y equals mx plus b, so this one is linear. And the last one, it is simplified, and I see an exponent here, which tells me this one is nonlinear. Question 11. Use the graph to find the intercepts, then interpret what the intercepts mean in the context of the situation. The situation is the graph shows the number of people, y, at a gym x hours after the gym opens. So it crosses here on the x-axis and it crosses here on the y-axis. So the x-intercept is when x is 12, y is 0. And the y-intercept is when x is 0, y is 20. So what do those mean? The x-intercept means there are 0 people at the gym at 12 hours, which just means it closes at 12 hours after it opened up. So there are 0 people after 12 hours. The y-intercept, the 0, 20, that means there are 20 people in line when the gym opens. Question 12. A fountain is spraying a stream of water into the air. The solid portion of the graph represents the path of the water, where x is the distance in feet from the fountain and y is the height in feet of the stream. Find and interpret any symmetry in the graph of the function. So again, symmetry, they're talking about line symmetry. So that's cutting it in half. So I could draw a line, a vertical line through here, which means it crosses at 2. So we would say the line of symmetry is x equaling 2. Now what does that mean in the context of this word problem? That means the highest part of the stream is 2 feet from the fountain. Question 13. Determine if each situation represents a discrete or a continuous function. So in this one, think if it's discrete, you cannot get part of something. Your domain is not part of it. It's all whole numbers. If it's continuous, you can have any part of the domain. So it says Amani pays $30 per hour for any part of an hour for her weekly piano lesson. So that is saying that no matter what part of the hour it is, you're paying $30 per hour. So if it's only half an hour, you pay $30 per hour. If it's 5 minutes, that's part of an hour, so you have to pay the full $30 per hour. So because I can have part of an hour and it doesn't change the cost, this would be continuous. The last one, as a private investigator, Tia charges $25 per hour for any amount of time up to 8 hours. That's a key phrase right there. Up to 8 hours, it's $25 per hour. After 8 hours, then it's a flat rate of $250 per day. That means anything after it, you automatically pay the $250. So there's a gap in there, so it cannot be continuous. That means this would be discrete. And if we were to be more specific, this would be neither, because part of it is continuous, so part of it is connected and the other part is just dots. They're separated, disconnected dots. Question 14, find all the extrema and determine if they are relative max or a relative minimum. So I see A, I have a B, I have a C, we got a D, and we have a letter F. So A is neither. B is top of a hill, so it's a high point, so this is a relative max. C is at the bottom of a hill, so a valley, so that would be relative minimum. D is at top of a hill, so that's a relative max. And F is at the bottom of a valley, so that would be a relative minimum. Question 15. Identify where the function is increasing and decreasing, and then determine the end behavior of the function. So you always determine the increasing, decreasing from left to right. So from here to here, it's decreasing. So that's going down from left to right. So for that one, let's do decreasing. So it's decreasing compared to the x-intercept. So this x-intercept is at 1.5. So when x is less than negative 1.5, it's decreasing. It's also decreasing from B to C. So we were also going to say when x is so let's say x is between zero and 1, and that's 1.5. That means the rest of it is increasing. It's increasing here, so it's increasing when x is greater than, or actually it's not greater, it's when x is between negative 1.5 and 0. Or you could say between A and B it's increasing. And then it's also increasing when x is greater than 1.5. Or you can say it's greater than, or it's when it's increasing when x is greater than C. Then the end behavior, just remember up here it's increasing, down here is decreasing, this is increasing, so when x increases, this is x decreasing. Now here, I'm just going to look at the arrowheads. The arrowheads are right here. So this one, y increases. On this side, y increases. So my end behavior would be as x decreases. So when I go to the left, the arrow is pointing up. Y increases. And as x increases, so when I go to the right, when x increases, the arrow is pointing up, so y would also increase. Question 16, find the root of the equation below. Root, remember, means the x-intercept, which means the solution to the problem. So I'm going to solve for x by adding 3 to both sides, and I get 8x equaling 16. Divide by 8, and the solution, the root, the x-intercept would be 2. And our final question. Use the description and the graph to compare the two functions. Which function has a lesser minimum, which just means which one goes down further, that has a lower lowest point. So we were comparing f of x and g of x. G of x is right here. So that goes about, we would say that was down to about like negative 1 point, we'll just say negative 1.3. That's just a rough estimate. Now in our f of x, you can see that has a relative minimum at 1.1. So 1.1, so a negative 0.4, which is over here, up to 1.1 would be roughly here. That's the low point of f of x. So which one has a lower one? That would be this point right here, which would be g of x. So that would be a quick review of graphs and functions.